3a to the nth power. Okay, we have, remember, always invisible exponents, which are ones. Okay, now I just made them visible, and remember we have to multiply external exponent by every single internal exponent. Okay, this is times n times 1, so I'm going to have 3, 1 times n, and I have a 1 times n. So this is going to be equal 3, 1 times n is n, and a 1 times n is n. So I have a to n. This is the solution to my problem. Let's take a look at this example. Anytime we have division, anytime we have fraction, we're supposed to simply apply the same rule. Okay, anytime I do not have exponent, there is always invisible one, and simply multiply external exponent by every single internal exponent. So I have 1 times 10, I'm going to have a 1 times 10 over, and I have to do the same thing over here, b 2 times 10, which is going to be equal a 1 times 10 is 10 over b 2 times 10 is 20, b to 20. Okay, I cannot reduce anything because I have different variables. Let's take a look at this example. Okay, in this case we have different bases, but we have the same exponent. Okay, we have the same exponent. So what we can do, we're going to apply this rule. Okay, we have different bases, the same exponent. So I'm going to take these two bases and put inside of the parentheses an exponent outside of the parentheses. Okay, so I'm going to have 24 over 12 to the third power. Okay, next I'm supposed to reduce the fraction. 24 divided by 12 is equal to, so in other words I have 2 to the third power. Okay, 2 to the third power is equal to 8. Remember, 2 to the third power is 2 times 2 times 2, which is 2 times 2 is 4 times 2 is 8. This is the solution to my problem.